We learned yesterday with the cosine, if you have two things added or subtracted in an angle, you can't just distribute the cosine. You have to use the formula to break it apart. Same is true for the other functions. So these are the last formulas we'll put on that tab. So we have a total of 6 on that tab. So if I ask for the exact value of sine negative 15 degrees. So we have to think about angles on the unit circle that we can add or subtract to get a negative 15. Minus 45 will give me negative 15. So now I'm looking at my formulas. I have sine 30 minus 45, so I'm looking at the sine of A minus B formula. So that says sine of the first, cosine of the second, minus cosine of the first, sine of the second. Again, we're not treating that angle as a negative 45. The minus just tells me I'm using my subtraction formula. So now this is the hand trick. Sine of 30 degrees. So remember sine, square root of the top over 2. So radical 1 over 2 is a half. Cosine of 45. So cosine, square root of the bottom over 2. Minus cosine of 30. So square root of the bottom over 2. Radical 3 over 2. Sine of 45, so square root of the top over 2, radical 2 over 2. You can write these like we talked about yesterday, either separate fractions or all together. So radical 2 over 4 minus radical 6 over 4. If I gave you tangent of 13 pi over 12, what do we need to do with that? Change it to degrees. Keep it what you did that way. So my pi's cancel. 13 over 12 times 180 gives us what? Okay, so I need two angles that would add or subtract to 195. Okay, so patiently waiting for me to give them an answer. Yeah, do you get one?
150 minus plus 45.
That would work. All right. So now I'm looking at my tangent formula. I have a tangent of something plus something. So my tangent sum is where I'm looking. So that formula is tangent of the first plus tangent of the second over 1 minus tangent of the first, tangent of the second. In order to evaluate tangent of 150, what do I need to do? Quadrant reference. reference angle. 150 is in quadrant 2. Reference angle 180 minus 150. Okay, in quadrant 2, sine is positive, so that means tangent's negative. The tangent of 30. So radical 1 over radical 3 would give me radical 3 over 3. Plus, what is the tangent of 45? 1 over 1 minus negative radical 3 over 3 times 1. Alright, so I have negative radical 3 over 3 plus 1 over 1 plus radical 3 over 3. Now, several things wrong with this. We don't want a fraction and a fraction, right? Easy trick, something we did with our proofs. This denominator is a 3. So what if I just took everything times 3 on top and bottom? So we get negative radical 3 plus 3 over 3 plus square root of 3. Now, is this really proper notation? No. Why? Radical in the denominator. Now, here's the deal. We have gotten radicals off the denominator before. Alright, I am going to allow you to leave your answer like this. But, just hear my stipulations. A, does everyone know how you would get that radical off the bottom? Multiply by the conjugate. I don't want you to leave a fraction and a fraction. So that was an easy fix to multiply everything by 3. You could have an equivalent answer on these that looks different. What I mean by that, if we aren't going to take this all the way down and rationalize it, there are other things that look the same or look different but are mathematically equivalent. So you might see something like 1 minus radical 3 over 1 plus radical 3 and this. And mathematically they are equivalent, but when we just look at them, if we haven't gotten the radical off the denominator, they're not. They don't look the same. So just know I might have my answer written differently and yours might be equivalent. Without going through the trouble of getting the radical off the denominator, how could you check if yours was equivalent? Can we plug it in and get the decimal and see if it's the same decimal as the other one? Absolutely. So don't just assume if yours looks different that you're wrong. Okay, actually take the time to check it and you're probably okay. Does that sound fair to everyone? Have tangent minus tangent over 1 plus tangent times tangent. What formula does that look like? So what's my A? My B? 100 minus 70 is 30, and tangent of 30 is? Do we need more problems like this? No? You guys are sure? I have more ready if we need them. We're okay? Let's look at, I really just have 3 types of problems. So there were those. Then we did some of these yesterday. And you had some on your homework. So if I asked you to simplify this expression, what would you do? Sine of 120 cosine of theta plus cosine of 120 sine of theta. Okay, the sine of 120 and the cosine of 120 degrees. We should be able to simplify those. What quadrant is 120 degrees? Reference angle. 180 minus 120 is 60. In quadrant 2, sine is positive. Sine of 60, radical 3 over 2. In quadrant 2, cosine is negative. Cosine of 60. And that's really all you can do on this one. They're not like terms because one has a cosine, one has a sine. Instead of plus and negative, you could write it as minus. But that's as simplified as our answer will get. So we're just using the formula to expand it, plug in any values we know. Why don't you guys try? And you do not have to memorize any of these formulas. They are all on the formula sheet. Okay, so you can think about it a lot of different ways. 3 pi is the same as pi. We know tangent is y over x, so 0 divided by negative 1 is 0. So we have tangent of theta plus 0 over 1 minus tangent of theta times 0. So we get do we need another one of those? No? Let's try 1 or 2 proofs and then we'll be done. Which side would you box in? All right. On the left, tangent of pi over 4 plus t. So we have to use the formula to expand this piece. So that's tangent of the first plus tangent of the second over 1 minus tangent of the first tangent of the second. All right, then we have the second one. So we do the formula again. The only difference is this time it's the tangent difference formula. So tangent of the first minus tangent of the second over 1 plus tangent of the first, tangent of the second. All right, from there, what should we do? Common denominator, but one thing before we get that. Yeah, can we do tangent of pi over 4? That's like 45 degrees. What's the tangent of 45? So we have 1 plus tangent t over 1 minus 1 times tangent t is just tangent t. Now I would get the common denominator. So this one needs 1 plus tangent. And this one will get 1 minus tangent. So if we multiply it out, we get 1 plus 2 tangent t is tangent squared t. On the denominator, if we FOIL, that's 1 minus tangent squared t. Over here. Now what? Yeah, you can add them together if the denominators are the same. The 2 tangent t and -2 tangent t cancel. Now look at our goal. I want 1 minus tangent squared t, which is what I have. But on the top, I want secant squared t. Look at this. I have a 1 plus tangent squared. What is that? In this fraction, I have a 1 plus tangent squared, which is, and secant squared plus secant squared would be 2 secant squared t. All right. Do we need another proof? You guys feel okay with all of this then? All right. So the assignment is the section 5.4 handout on Classroom.